have patience to do this, John. Write the power as words of a product. So in words, 1/5 with the exponent of 1 is the same as. It's the same as 1/5 to the first power is what I would say in words. And then as a product or as multiplication, as a multiplication, I'd say 1/5. And how many times do you need to multiply 1/5 by itself to get 1/5? Just once. Just one of them. As a product, it would just be 1/5. Because there's only one of them. I would say this is 3 to the 4th power. And as a product, I would write this as 3 times 3 times 3 times 3. Three times 3 times 3 times 3. 3 multiplied itself 4 times. And the last one, there's a variable, but it's still, I'd say this is p to the 3rd power. P to the 3rd power, or p times p times p. As a product. Okay. Oh, we could multiply 3 times 3 times 3 times 3 times 3. And is anyone a whiz and knows what that is off the top of their head? What's going on? What's it? 243.
Somebody's gonna calculate.
Okay. I'm sure they did. I don't know why you do that in your head, but
That'd be pretty scary.
you can multiply 81 by 3 in your head. D squared, oh, and D is a fraction. Uh-oh. We're going to use fractions all year. And if you're not familiar or comfortable with fractions, we're going to ease you in. First one is up front. D squared when D is 9/5. So if I want to, well, let's first rewrite D squared as a product. Kind of like we did this one. So what would D squared look like as a product?
D times D.
D times D. Thank you. D squared as a product should just be D times D. Well, that means that if I plug in 9/5, I should just plug it in for both those D's, and that should mean that's the same as 9/5 times 9/5. Okay? So then, now I'm going to do is, the only thing left to do is figure out how to multiply those two fractions together. Anyone remember how to multiply two fractions together? Cross multiply is what happens. No.
When you're dividing.
Stop. Cross multiplying you only do when there's an equal sign between them and you're trying to solve an equation. There's no equation there.
Oh.
So then what should we do instead? Just multiply across the top, multiply across the bottom.
That is what that.
Multiply straight across.
Come on.
If we're only multiplying on one side of an expression, then we'll multiply straight across. So that means that 9/5 squared is the same as 81 over 25. 81 25ths. From there, you could try to reduce that, find something in common at top, bottom. Stretching. If you could try to reduce this, find something in common. In fact, there is nothing in common between 81 and 25 as far as factors go. So you'd be done. There'd be nothing more to reduce there. You can leave it. Please leave it as 81 25ths. If you really have to, and you have to rewrite it as a mixed number because that's just the way you've always done things, and you really want to see it written like that, then that's okay. I won't mark you wrong. But feel free to release yourself from those chains that bind you to mixed numbers, and you just leave it as an improper fraction. What's our reminder tool for orders of operations from way back in the day? PEMDAS. Please write it like this.
All spaced out.
More importantly, please group M and D and A and S together. There's a specific method to my madness why I want you to do that. In particular, let's look at the first one together. 6 plus 12 divided by 3 times 4 squared. What's the first thing we need to do to try to evaluate this correctly? Exponent. There's no parentheses, so we'll do exponents. So that gives us 6 plus 12 divided by 3 times 16. What's the next thing we need to do?
Multiplication. Yeah.
Multiply or divide, whichever one comes first, left or right. Divide is the first one that comes, so we'll do division. 12 divided by 3. So we have 6 plus now 4 times 16. What's the next thing we want to do?
4 times 16.
Finish the multiply, so we have 6 plus 64. So then what does this expression evaluate to?
70.
Exactly 70. Okay.
That is just so.
Brackets count as grouping symbols. Anything that's the same, brackets or parentheses all count as kind of the same thing. So anything inside of grouping symbols. So here's brackets. Are there any more grouping things? Yeah, there's the 2 plus 6. So we'll work all the way down to the inside to get work from the inside out. If you would, should have gotten 12 for your first answer. Brackets, then we'll continue with PEMDAS inside the brackets. So there's more parentheses, so we'll solve the parentheses first. You get 8. Or 32 divided by now 8. 32 divided by 8 is 4. 3 times 4 is 12. Inside parentheses, so 4 minus 1 is 3. 24 divided by 3 is 8. The last one is the tricky one. So we have parentheses first, so we're going to look directly inside of these. Once you're inside the parentheses, PEMDAS rules still apply. So we're still going to work more grouping. Is there any more exponents? Then we'll look multiply, divide. Then we'll look add, subtract. So if we're just looking inside the parentheses, what's the first thing that order of operations says we need to do? Exponents. Exponents. So before you go and add the 6 and the 5, you better figure out the exponent first. So we better start with 48 minus 6 plus 25. We'll figure out the exponent first. We're still inside parentheses. They're not finished yet. So we're still inside. Now we can add and subtract. And now you'll get 48 minus 31. There's nothing more inside parentheses, so now we can look outside, and there's only one thing to do, add and subtract. 48 minus 31 is what, 17? 17. When we evaluate these, we can do, say, this is the same as 10 times 3 over 2 times 3 plus 2. If you want, you can also do this to make sure that we're staying along. This division bar is grouping the top and the bottom together. So make sure you evaluate the top, evaluate the bottom, and then divide. Or you should have your fraction. In either case, you get 10 times 3 is 30. And you get, let's see, 3 plus 2 is 5. 5 times 2 is 10. And what's 30 over 10 the same as? 3. You get 12 minus 8 minus 1. So we'll subtract going left to right, and you get 4 minus 1. Hey, it's also 3. And then when we plug in the last one, we take out the y and put an 8 in. That's still squared. So we get what? 64 minus 3. 8 times 8 is 64 minus 3. Which gives us 61. 4 copies of a science report that he made. He copied each report. 20 were black and white and 5 were colored. He paid a copy center to make and bind the copies. His cost is given by that expression, where C is the cost of color and B is the cost of a white page. And what is the total cost if color costs $2 and black and white costs 5 cents? Well, some important info we can get out of that in particular. We know that there are 20 black and white pages and 5 color pages. We know that the cost in dollars is given by that equation. We know that C is for color pages and B is for black and white pages. Then what's the question? What are we trying to find when we're done? What number do we want in the end?
Total cost.
Total cost. We want to know how much money we spent. So how can we do that? Well, what's an expression? What represents the total cost? It's actually told to you, an expression for what represents the total cost. What's a formula? What's a expression? 4 times 5C plus 20B. So from here, if we knew what C was and we knew what B was, then we'd be home free. Oh, we do. It tells you that the cost of a color page, which we said earlier was C, is $2. So C equals $2. And white copies, or black and white copies, excuse me, B is 0.05. And you could plug those numbers in, and it would give you an expression for how much money we spent. Or 4 times 0.05. And evaluate. You get 10 plus 1, so 11, $44, I believe. Will be the total cost. The total amount of money it's